Okay, so this symbol is like the proper subset of. So it is kind of like the inequality that is like lesser than or equals to. So if A has elements 1, 2, and 3, while B also has elements 1, 2, and 3 as well. So you can say that A is a proper subset of B. But then if we go to the next one, right, this symbol represents the subset of. So it's like a lesser than, strictly lesser than inequality. So we cannot use this subset with this top example of A and B because like A is not strictly lesser than B. But then in this scenario, A equals 1, 2, or 3 and 3, right? But then B has 1, 2, 3, 4, 5. So in this scenario, we can say that A is a subset of B. And this symbol represents not a subset of. So let's say if B, the largest set B has 4, 5, 6, 7, while A has 1, 2, 3, you see there's zero elements that there's no elements that are equal inside, and 1, 2, 3 is not inside B lah. So A is not a subset of B. Then you see the union over here, right? Union is kind of like the two sets combined to form one set. So let's say A is like 1, 2, 3, right? While B has 3, 4, 5, 6. So the union of A and B is 1, 2, 3, 4, 5, 6. We do not need to repeat the 3. So the intersection is like the same elements in both sets. So if we use the same example over here, the number 3 is the same, right? So the intersection of A and B is 3. And this symbol represents is an element of. So A, let's say this set A, right, has elements 1, 2, 3, and 4, right? There's a number 3 inside the set A, right? So 3 is an element of A. And then this symbol represents is not an element of. So let's say you have the number 5 over here, right? So number 5 is not an element of the set A. The set A doesn't have the number 5. So the natural number set, this symbol N represents the natural number set. So it's like 1, 2, 3, 4, all the positive integers. So this weird looking Z represents an integer set. So it's just this set over here, negative numbers, positive whole numbers, and 0. So rational number set is is like is a set where all the numbers can be represented by fractions a over b, where a and b are both integers. So the next set, the real number set, it is a set with numbers that can be represented on the number line. And then this Greek letter C, this letter U, and this letter E can represent the universal set, which contains all elements in like a specific context. Then uh, a zero with like a slash through it, or just brackets with nothing inside, represents like a null set, which is a set with zero elements. So the next one, A prime, right? This prime represents a complement, which means there's not A. So if you see here, right, the universal set has 1, 2, 3, 4, 5, 6, 7, 8, right? But then A has 4, 5, 6, 7, 8. So A, the complement of A is just 1, 2, 3.